Oh, we need some light. So I don't understand if and how the the chat on, I don't know, on X should work. I'm really confused. So can someone, I don't know, like in a normal chat? Probably not, right? At least the stream is online. Hmm. Okay, let's go with that. Let us go with that. Okay. So that works here. Okay, right. Um, test me. I'm online. Hooray. Yippee. So that works here. Okay, right. So that works, but for some reason the Discord integration doesn't work. I don't know. We should get this fixed. So keep a Discord community in the loop while you go live. Automatically share all your restreamed chat messages directly into Discord and from Discord to the restreamed chat. What? So keep a Discord community in the loop while you go live. Okay, so that works. All your restreamed chat messages. I still have my stream open somewhere here. But the way back doesn't work. Let me try on Twitch, but
right after this, we're sending the first team home and the first team through.
sending from here to Discord work. No, it does not. So this is really weird. Okay, so we don't care about that now. What we do care about is notifications and this here. And can I put that over here? Like this? Okay.
Halarutan. Hello from Discord.
Perfect. Okay, so we got that going. So I think it's really weird that you can't, basically that's not reflected in Discord. So if someone types something on YouTube or on Twitch, that we're not getting notified in Discord. Because it's so much, I mean, it's so confusing, right? Probably I would have to have YouTube open, Twitch open, X open. That's weird. I will just ignore that now and rely on Restream to relay the messages. Okay. So let's start Let's start the IDE up. So I thought I'd try to do some improvements, but then I stopped and I thought, okay, I can also do it just live. So that's there, but for the moment, I think I want to start with something else. So I want to open the Zig plugin. And because one thing that bothers me a bit is that basically increasing the selection doesn't work well. So if I'm here, right, I can do this, and it selects the plus, and if I and then it selects everything, the whole block. And this is weird, because next it should probably select, so the plus is here, so the next expression upward is this, and then probably this, and then maybe the whole assignment, and after that it can get the whole block. But that doesn't work. So let's see, where are we here? Okay, the question is, I'm not sure. So why is info? Okay, so we don't care about the arrow right now. So I don't know, because I don't remember that you have to implement a custom, basically increase or expand selection and decrease or shrink selection extension point. It just works from the abstract syntax tree, from the PSI information. So okay, and probably that's where we should start. So when we take that here, let's see. Let's take that and go to tools and view PSI structure. Okay. So then there's zig file. There's an arrow element because so okay, I just want to see if we can. So we have if we could basically, so right, and this is how it's supposed to work. So let's say I start in the addition here. The next expression it should select, if it goes upward, is this one. The next selection it should is this, or maybe that one. Then this, then this. Okay, so this is how it's supposed to work, but it doesn't work like that. So the PSI is okay. And I honestly don't remember if we have a. So where should, so it's not in, it should be in the core module, in the language module somewhere. Maybe here. Editing formatter injection. Pairing. We have a brace matcher and we have a quote handler. So let's see. So we have a brace matcher, and let's check. Okay, so this is the core. Okay, so we're in the correct thing. So we got a color settings page, a brace matcher. We have a self-managing commenter, formatting, model builder, parser, quote handler, syntax highlighting factory. Okay. Okay, let's quickly check the documentation, and if we don't find it, IntelliJ SDK docs. There you go. So maybe we got that under custom language support. So registering a file, sorry, let me make that larger. So code completion, find user rename, save code formatter. No, structure view is, it's not. Surround with, go to class. Inlay and spell checking. Additional minor features. So here we got brace matching. Comment code, code folding, join line smart enter, move left and right. Return children, okay. Move statements up and down. Reader mode, customized copy path, no. Refactoring, it's not here. So and the and the action is, I think, extend selection. We can find out. So if we go to CLine here and say tools, internal actions, and then it's UI, no, it's not UI inspector, it is UI debugger. You got it here. Can switch to actions, can go down here. Okay, and then I can go here and press it. So editor, select word. Okay, it's select word. Okay, and what's when I do it? Editor, unselect word. But okay, so wait, is it really that action? I thought it was a different one. Let's go here, open any file and say like this. Okay, now we can. Okay, so what is that? Is that the same action? Internal actions and UI debugger. Oh, it's select word. Okay. Okay, so basically we have two questions, right? The first one is, do we need to implement something in there, or should it come out of the box just because it has the model for the syntax? Or if we don't have to implement something and it should come out of the box, why does it make big jumps like that? Okay, so let us prepare to burn some tokens. Okay. All right, then we go to, I think I have it in temp, ZigBrains. When selecting, when extending or shrinking a selection in a source file, in a zig source file, the selection doesn't jump to the next bigger expression. AKA, it doesn't jump to the next PSI node, but instead leaves several parents out and decreases the selection too much. I have two questions. First, is there a specific extension point that needs to be implemented to make the actions? Now I forgot it already. Where is... Oh, I closed it down already. Oh, good. No, maybe I still have it here. Yeah. The actions with ID editor select word and editor I think it wasn't a capital one, unselect word. Behave properly, question mark. If no, what could be the reason that the behaves incorrectly in the ZigBrains plugin, question mark. Okay. Your task is to investigate this issue. Use IntelliJ Research Quick for IntelliJ platform specific how do I have to write that, right? Because it's platform specific. Like this, is it IntelliJ platform specific or is it IntelliJ platform specific? I don't know. Use IntelliJ Research Quick for IntelliJ platform specific questions. Okay, go. So in the meantime, let me check OBS. Okay, we have an image. I'm back in 1 second. The only thing I really can think of is that because they're using a BNF, so they use GrammarKit, I'm pretty sure about that. Maybe this makes some of the internal nodes kind of transparent, right? So that they're jumped over, and you have to. Okay, so we need to see, right? The good thing is the IntelliJ researcher here, this sub-agent, has access to the whole GrammarKit source code and also the documentation. I see. Okay, I'm contemplating whether interesting extends. Okay, indicates that all expression rules share a common interface, possibly public PSI. I think I should check the documentation for specifics. It's crucial to point out. No, it's crucial to point out the correct action ID, which is editor unselect word, not the user's version. Okay, yeah. Make sure to clarify this accurately. I might also want to look into tests related to the selection pipeline, like select word without C test, for insights into the actual functionality or functioning. I mean, don't get all worked up because I just forgot to capitalize the S. Skips any empty white space. Yeah, I know that. Elements. This could lead to odd behavior, but no, it's not, right? Because we were inside a pure source code line. I weren't even white space. Okay, short answer. No special language. Okay, so that's what I remember, right? Because for my plugin, I didn't implement anything. Specific hook is required. For basic PSI node expand and shrink. The platform already does PSI parent-based selection. The plugin only needs to add extend word selection handler if it wants extra intermediate ranges beyond raw PSI range. Okay. Yes, I know what a plugin must provide. For plain PSI-based growth and shrink, nothing beyond the correct PSI tree, and we have a correct one. For extra intermediate steps, implement the extend word selection handler.
Sir_elf_man. What you doing?
Hey, sir. Hello, sir. So we're doing three things at the same time. So we try to implement a very small demo in Zig that I can show in 1 second, right? And at the same time, we try to understand all the quirks of the language plugin, the Zig language plugin for the IDE, right? And right now, we're looking into the following. So we have here some Zig code, right? And what I should be able to do is I can increase or extend and shrink the selection. So I can mark this word. And the next thing that should be marked when I extend more is probably this whole expression, right? And after that, this, and then the whole line, and then it's allowed to select the whole block, basically going up the parse tree. So, but what happens instead is it selects the word and then it jumps directly to the whole block basically. And I think that's unfortunate. So we were looking into the plugin if it does something weird or wrong that we can spot immediately. And that's what we do. Okay, so let me show you what we're working on. So let's see. We're working on just a simple graphics effect. So nothing dramatic, nothing
Sir_elf_man. The plugin re-implements a Zig parser. Sir_elf_man. Question mark.
Yes. So, and the reason is, so it needs to do that, right? Because if you're having, it's pretty easy. Okay, so it's really easy to understand. So if you have, no, I will all do on the command line, right? So if you use or if you would reuse the parser of the compiler,
Sir_elf_man. Whoa, send me the source to that cool Raylib program.
Yes, I will put it on GitLab. If you join the Discord, I can basically share it there, right? Let me see. I can't even find my, here you go. Wait. No, we don't want to edit channels. We won't go to chat. And then I can do something like
Sir_elf_man. I want to implement that program in my toy language, haha.
Wait, give me a second. Why doesn't it send it? So I can't send. So if you type socials with an exclamation mark, you see the link for. If you type social with an exclamation mark before, you see all the links too. So, and I can share the link to the GitHub repository in Discord easily.
Sir_elf_man. But manzig is one ugly language. At symbol for min is a macro?
No. So, okay. So what you need to know is I set out to simply look on the language because I heard it for several years now. And there was a pretty nice interview with the maintainer of Zig that I liked very much. And I thought, okay, so come on, let's look at the language. I work with so many stuff and I never looked really. So, and my knowledge is based on maybe yesterday or the day before yesterday until now. So this is how much Zig I know, okay? So, and what I understand is that these with the add are built-in functions, right? So I could also do something.
Sir_elf_man. I'll wait till Jay comes out before trying out Zig.
Ah, Jay. Is Jay actively worked on now that everyone uses just AI? I know it's I know the language because I saw it when it started and when what's the name of the guy? The grumpy one. I really like him very much. So when he started working on Jay, it was really great. I enjoyed these streams. So, but
Sir_elf_man.
Jonathan Blow.
Jay Blow.
Thanks. I blanked out. Exactly. So is he actively working? Because I never see him working on the language anymore. He's just playing.
Sir_elf_man. He's very grumpy, but Jay is very active. His game comes out soon.
Ooh, I didn't know. I thought maybe because I can imagine he's really, really unhappy with all the AI agents and no one's coding by hand anymore.
Sir_elf_man. Demo of the game comes Monday. I'll try it.
And this is still the game, right? Where you have these squares and you have to move and then you have to do certain actions and you can, I don't know, open certain gates and transition from one place to another and move things away. It's still that one, right?
Sir_elf_man. Yeah, looks like it.
Okay, wait, I need to turn off that it always says the names. Read nicknames, no. Okay. Yep. Okay, so I think that's it. Yeah, it's really, so what I really, really like is the graphics there. It looks so, I think the best word I find is slick. It's really spot on, right? But on the other hand, I mean, this guy has years and years of experience implementing games.
Yeah, I want to try it on my Switch too.
So he's basically publishing it not only for PC but on Steam, I guess. I don't know because I don't really know how this how you would do that as an indie developer. And when it's on Steam, you can play it on your Switch, or does it really? Does he really publish it for the Switch and for Xbox and PlayStation? How does it work? Okay, so right, what I was saying is, I think these are so-called built-in functions.
Just different platforms. Switch 2 is a closed ecosystem, so no, you buy it twice, I guess.
Okay, okay. Yeah, and you see there are others, like here into float or float from int and so on and so forth. Yeah. Okay, so anyway, so what I was saying is that here we basically try to get an understanding why this doesn't work, and we were looking at the code, and we were asking an agent basically to explain if there could be something wrong in the plugin. So extend word selection handler javadoc explicitly says the default behavior is based on the underlying PSI tree. Okay, so if that is true, and the PSI tree is okay as far as I saw. Runtime chain. Okay, select word at caret.
I feel like this needs to be done with a debugger rather than an agent.
Yeah, so, okay.
You run the command and a breakpoint fires.
We could do that, but then we need, it's really hectic in there, right? So so it's, in that case, it's easier to go basically not in with a debugger right away, because you're really deep into the platform there, because, and I showed that earlier, right? So if we take, for instance, that thing, right? Only that bit of code, we can look at the abstract syntax tree representation that IntelliJ has. If we have here, we go to view psi structure, then we use that. It's building the psi tree. So, and basically, this is what's going, or what should happen, right? So you have the psi tree here on the left, and you see what it is, right? And that's basically okay. So, wait, I'm just clicking in. So if I'm, for instance, here on that, or on that one, right, on the X. So when I press extend selection, it should jump to the next parent, right, which would be that one. Okay, and it would increase the selection to this. And if I press it again, it should jump to that parent, which is with the brackets, with the outer brackets, except, and I implemented that in my language like this, that it skips that step, right? And then go to the next one, which is the whole left hand. And then it goes to this one, which is the whole expression. So, and that doesn't work. So, and it works for everything, for all the languages, right? If we switch to Kotlin here, for instance, right, you see exactly that what happens. So if I press extend selection, it selects just the identifier here, then with the access, then the whole basically rule, and then everything, and then the when, and then the whole function, and finally with the braces, and the last step is the whole class, and then comes the whole file. So this is, and we can do that in reverse, right, which is really handy. And that's why I think that the error could come from how they built the parser, because they built the parser from using a parser generator. And I think if they used expressions, I'm not sure if you heard of expression parsing. Everything is basically an expression, and you have these deeply recursive things. it could happen maybe that there's something wrong there. But let me read the rest of it. Okay, so builds a chamber wrapping the action space handler with editor action helper. For select the effective flow is select word at caret action. If caret is on, okay, so that's completely uninteresting, right? Because how psi ranges are collected. Select word handler commits the document, finds psi element at the adjusted caret, handles white space, empty elements, and calls select word util process ranges. Okay, so maybe we should go up to the main agent and read what he found. So first, so my initial question was, okay, wait, let's move where I asked the question. So my question was, is there a specific extension point that needs to be implemented to make the actions with ID editor select word and editor unselect word behave properly? And the second question was, if no, what could be the reason that the editor select word action behaves incorrectly in the ZigBrains plugin? So, and the answer is first, yes, but only if you want extra intermediate selection steps. Okay, so we want extra intermediate selection steps. Without that, editor select word already works off the PSI tree by default, and that doesn't work, and that doesn't happen, I mean. And editor unselect word shrinks through the same collected ranges. There is no separate unselect extension point. One small correction from the platform sources, the action ID is with a capital S, I know. In ZigBrains, the most likely reason is the PSI shape, not a missing mandatory extension. What I found, okay, so there's no extend word selection handler. We already checked it before. The Zig grammar has a long expression wrapper chain. So this is what I was talking about earlier. Expression is bool or expression is and so on and so forth. So we could look on the BNF. Those wrapper nodes often have the same text range as their child, okay? IntelliJ expansion chooses the next strictly larger range. Okay, the grammar also uses many private helper rules, and those do not create psi nodes at all.
Same text range sounds fishy.
Yeah, so I think, so the whole expression parser thing is basically used to unify basically the parsing. Because if you look at math expressions, right? You have it's really hard to explain. Let's skip that. So so expression parsing is generally really nice if you have these kinds of mathematical expressions, right? Because everything there is an expression. So you can say, okay, this is an expression, fine, but this is also an expression. So, and you don't have to write down all the combinations that are possible, because since this is an expression, you just need to say, okay, plus is, for instance, an expression plus an expression, right? And you covered basically everything. And that's the good thing about these this expression parsing. And I think there are tremendous advantages when it comes to speed and how fast the parser is. So, and to your question, right? Why does it need a separate parser? So, if you would say, okay, I want to reuse the Zig parser that is already in the compiler, that wouldn't work, right? Because the thing is, if I do something like this, let me just remove the semicolon here, right? And then you say something like Zig build run, you get an error.
Separate parser needed cause you need whatever Ask JetBrains needs.
Yes and no. So yes, totally true, right? The plugins are written in Java, and so it's really nice to have Java. But one of the major reasons is that while you type out code, you have wrong code 99% of the time. If you think about it, right? So the parser you're writing is not allowed to complain when you write wrong code. It needs to read still all the rest of the file, even if there's an error here, right? Because otherwise you can't do highlighting, code insight, navigation and stuff, right? All the smart things would fall apart if the parser says, oh, there's an error, I'm quitting.
It needs to synchronize after an error.
So the parser needs always to parse the whole file, even if there's an error. So, and usually none of the parsers that are implemented in compilers do that, right? If they see an error, they stop because there's no reason to go any further. It's useless, right? The program won't compile anyway.
How nice that Zig has semicolons, makes sync very easy.
Exactly, right? So and then your job basically when you design the parser for such a plugin is to say, okay, the parser must not be confused if I delete
iViewer
this here.
Streamboo, com.
Let me wait. I need to block the AI viewer stream something because they spammed us yesterday already. So where is my channel? Here we go. Block. Yep. Okay, that's it. So you see here, right? I removed the one brace, and the whole highlighting falls apart, right? So in a real stable highlighting parser, that shouldn't happen. But to the credit of Zig, Zig is using the I think the Zig language server behind. And I'm not sure how much it contributes and what the language server does when the file is completely wrong, right? But if we go, for instance, here do we have a bit of more? Okay, so that's pretty small. So something is obviously wrong here because
probably stopped at the parsing stage and didn't pipe into checking.
Yes, and that shouldn't happen, right? So, and I don't know why I have all these errors here because I didn't change anything.
If you mess up hard enough, Rust does the same in its LSP.
Yeah. Let me clean that up. And let's see. Otherwise, we need to drop all the caches and stuff and the indices. What has expired? Because cached version JSON has expired. Okay. It's still wrong. So the plugin built successfully, but here we get an error. Okay. Invalidate caches and restart.
Lol. This is the JetBrains experience?
Yeah, it seems so. Let's report it. I don't even know what version I'm using right now.
IDK man, I haven't touched Java in maybe 10 years.
What languages are you using? I guess Rust?
C and C++.
Oh god. So C is nice.
C++ at work.
Never got really warm with C++. There are so many rules, right? And then
it's like 100x worse than this.
Yeah. It's not that I didn't write C++, but
compile time's approximately 40 minutes. So kind of chill at work.
Yeah. But I think J is really nice for that, right? So what I've seen is that Jonathan really worked hard that the compiler is pretty fast. Okay, so now we got that. Now we got that working. Okay, so now what I wanted to show is, so let's see, we do something stupid here, right? Like okay, let's do something really stupid. So we have an open brace here. We have an open brace here. Let's remove that one. So see, the highlighting doesn't break. And it just shows you basically several more. I mean, nothing is right. If you're missing something, nothing is wrong anymore. So, and it says, okay, missing thing. And of course it says that override cannot be applied because we're now inside the init block, right? So you need a really robust parser for the language. Okay, so we got that, and I wanted to read the thing here. The grammar also uses many private helper rules, and those do not create PSI nodes at all.
My Toylang has a pretty craptastic parser, hee.
So your language is written in C++, I guess?
C.
C, okay. Fair. So C is right. I mean, C has its problems, but if you just think about, okay, so you can do stupid stuff and shoot yourself pretty easy, but it's a really nice small language. I really like it.
I'm only here because I'm stuck on an annoying problem, hee.
So you're procrastinating. So, and in your Tor language, do you
doing escape analysis right now?
Yeah. Do you use in your language a parser generator, or do you write the lexer and the parser just manually down?
Manually, it's all recursive descent.
Okay. So so for the language I wrote and plug in for, I used a pret parser like this. Pret parser, and that was really nice because I wrote a parser for the Wolfram language. I can show you.
It's an indentation-based lang, kind of like Python. I think I regret it.
Indentation base is, I mean, you need to keep track of all the of all the white space and stuff, right? So I wrote a I wrote a parser for the language here from Mathematica, so it looks like that. What could we do? I don't know. Something like that.
But it looked like pseudo code, so I kept it.
It looks like this, the language. And you see it's all, this is all expressions, right?
Shocked face.
So you have a strict expression tree here. Right. Okay, so structural selection. Okay, so I wrote that down. So
that's beautiful.
Shrink and extend selection doesn't work too well. Yeah, so and the thing we implemented in Zig was really just one line of code. Nah, wrong file. Maybe that. Yeah. So the thing we try to implement is really these, I don't know, make it 3 lines, maybe 4 of code. That's all. And what took so long is basically implementing the gradient filter. So
that's incredible.
Yeah, there's lots of stuff, right, that's provided here. So you can easily just create a random matrix. Then you make an image out of it that looks like this here. And then you wrap dynamic around and it just loops and updates everything. And the only thing you're doing is you take the original image, you calculate the gradient filter of it, and then you add them together and assign it to image. And then you colorize it. That's what you see on screen. But then this happens over and over again.
The best I've done in my lang is write snake lol.
But snake is not too bad, right? It's okay. So if you wrote snake, I guess you needed some graphical interface and stuff, right? So did you use, for instance, Raylib for that, or did you implement
and a ray tracer that is slow because of GC?
Okay.
Yeah, it's Raylib.
Okay, so you can make connections basically to C libraries. Nice. Okay.
It's an embeddable language, so it's by design able to use other libs.
Okay. Okay, so if we look, let's take a peek, a small one on. So how was the file called? Zig.bnf.
I even got it working inside Rust, but got a bit tricky with the garbage collector.
So you manage all the memory, right? So just like in Java, you don't have to do anything. Everything that's not used gets just garbage collected at some point.
Yeah, very similar to how Java works.
Okay, let me see.
Which is why I'm investing into escape analysis.
Okay. I need to check what escape analysis is. Let me take a browser.
So far results show approximately 60 FPS boost in heavy math benchmarks.
Okay. In compiler optimization, escape analysis is a method for determining the dynamic scope of a pointer. Okay. Where in the program,
but I keep messing up the theory, which causes a seg fault.
Yeah.
Loops really kick my butt, haha.
Yeah, so in the Zig code, we also need to do some optimization. I just wrote it down from top to bottom, and we have intermediate memory blocks that we use to whatever. They are always the same, but I always allocate them and then free them at the end. So this is bad, and I was starting to fix some of the stuff. But then I remembered that I wanted to look into extending the selection and how that works. So let's see. Can I
I think I spent around 1 month making indexing into arrays fast, since I have bounds checking.
Okay, yeah. So GrammarKit is not available. Okay, so it's written with a minus. Okay. Let's install it. Okay. And now we got highlighting for that. So I want to see. So what does ZB stand for? Maybe, ZigBrains, okay. So if statement body is private. Okay. So, wait, let us quickly check again. So for instance, something simple like here, right? So if I do that, I get the less, and then I get everything. So everything else is skipped. Okay, so let's see what this is and see if we find it in the BNF and see if the node there is private. I'm really bad at talking and doing something sensible. So C structure. No. Okay. So we got we were here somewhere, comparison. So we Zig compare expression. And then we were in the middle. So it skipped that node, Zig compare expression. Let's see. So we got compare expression. So I think the most likely, because we see them in the tree, right? The most likely explanation is that these are all expressions, and if they have the same range as their parent, so this is an expression, bool expression or something else. Okay, so what else we got? We got Zig compare expression, and then we have if prefix. If is also an expression. If prefix. If expression is if prefix Okay, so this is also an expression. So where does it stop? Wait. Maybe we do need everything. Do we have something that is smaller? So what is here? Okay, no. It selects everything, including the comment. Zig container implementation. Let's say it stops at Zig container implementation. So we got container. So primary type expression. Is that used somewhere? Okay, so everything with an expression. Everything with an expression is also an expression. Okay, so let us ask one more question and say, I checked the zig.bnf file, and indeed most nodes are expressions. What would be a reasonable approach to make extend and shrink selection work if most of the tree is made of expression nodes? A reasonable approach is to treat this as a selection range problem, not an expression inheritance problem. Expression being the common base is fine. What breaks editor select word is that many expression parents have the same text range as their child, and the platform only moves to a strictly larger range. Okay, so add a Zig specific extend word selection handler, make it work for Zig PSI broadly, ideally expression plus a few delimiter heavy constructs like block, group, and so on. In select, compute a list of meaningful strictly increasing ranges and return them sorted smallest to largest. Deduplicate equal ranges aggressively. Okay, what the handler should add. Add ranges that are meaningful to user. Not every grammar wrapper. Okay, full expression range when it's larger than the current selection. Expression interior without delimiters. Okay. Do not try to mirror every parent PSI node exactly. If your grammar has same range wrappers like two good options. Okay, one broad handler for Zig expression. Walk up the Zig PSI parent chain yourself. Collect candidate ranges from enclosing expressions and constructs. Remove duplicates for non-growing ranges. Return the final ordered list. a few targeted handlers. Okay, so no restructuring of the grammar. If some precedence nodes exist only as same range wrappers and are not useful elsewhere, making some of them private can reduce PSI noise. But that is a grammar design cleanup, not the main fix. Rule of thumb, selection steps should feel like, okay, yeah, I get that. Okay. So we'll leave it like that. And let's continue actually here. So what I was trying to understand is, so this one here is basically mirrored from how Zig itself implements complex numbers. So, and we want to store some of the things. So let me quickly check back here. So basically everything is defined inside the return struct. Okay, so okay, so we need a type for that. Like that. I need to check, so still too new. Yeah. Okay, so what we need is definitely, we want to have, okay, so const and x, or let's call it width. And do I make that undefined? No. Okay. So width is of type, I don't know, maybe you (16). I think that is not a semicolon, is it? Oh Christ, I'm struggling. Okay, what? So these are the things that confuse me, right? Because here we have commas. So, and this is probably, okay, so I don't need a const here. We just define width, height. So we need definitely dx image. And now I'm already struggling because how do I say it's an array of type dy image. Let's see if that works. I don't know. Okay, so we need that, we need that. What else do we need? Okay, so the normalization factor. Let's call it scale. This is also of type T. So then we need these two arrays. Okay, so YP and YM. And YM is also of that type. So, okay. Now, how do we handle that? So I think init returns a type T, and okay, so let's just write it down if that works. So we need init, and this returns, no, not type T, self. Okay, so I write down self because self is the type, and this is, okay. So self is the type. What does it say? It's not used. Name shadows primitive. Okay. What? Why are they allowed to do that? What? Oh, I did it wrong. Has no body. And I think we need to return something. Okay, so always commas, that's weird. So no comma at all and no semicolon. Okay. Oh, let's see how much we're breaking that. So we need this here. X. So is there an exp? Oh, there is an exp, a built-in one, which is supposed to be faster. And I think for cosine and sine, they also do exist. I think if we go to sine trigonometric function on a floating point number in radians, uses a dedicated hardware instruction when available. Perfect. Okay, so we got that. Now, here, So here it knows that it's that, hopefully. So we might need to rearrange that, but we can put that here. This also goes into, can I do that? And then I say here, like this. Obviously not. Invalid left hand side to assignment. Okay, so like this. No, that doesn't make sense. Wait, why is it invalid for me? Ah, okay, yeah, I know. Okay. So here we want to return self, and now we should have an instance of that, right? So, and I think maybe there's no comma. But we probably need this here. Okay, so we're returning an instance of ourselves. Okay, and here we need to do all the setting up. Okay. Bam. So we can kick most of the arguments here. Let's do that for fun. So now why doesn't it know that? Use of undeclared identifier sigma. What's this? Return struct, it should be okay. So now I need to, okay, so I don't understand. Okay, let's first try it here. So this is sigma. If I want to access it, I need to write it like this. Let's quickly check. So Okay, so wait. So this needs to get, like in Python, it needs to get like this, and then I say self sigma. Okay. Same here. Okay, so we got that. I think this is okay. And honestly, this is just called once, and it's not. So if this is possible, we should keep it like that. So why is this still F32? It should be T. Okay, let's care about that later. And that goes also in here. And let's put that here on top. So what if these are not public? Because they should never be called. So once initialized, once initialized, the question is, what are we going to do here with the main? So in main, we have this image, right? And for that, we create a one-dimensional array. And then we just say, okay, we take this array and put it into our image. And we only need to do that because we need to load the texture from the image. Yeah, so we will go with that. And a story. So this thing gets a Sigma. It gets an image. It gets the width. It's the height of the image. And it also needs a mix factor, which is T. So we say mix factor is mix factor. Then we say is width and height is height. Okay. So and then we need to initialize all the other stuff once. So let's start with the normalization factor stuff. Here I want to say, so we really need to, so we can never change Sigma for one instance. Now at that point it needs access to the instance, because what I want to say is if self dot like this, return self dot, okay, so let's give it a self. Scale factor. So we need to do here Okay, so we got that. Now we need these arrays. Um, the thing is, we have different length. So for the width is it's not the same as the height. That's tricky. So these can be only be set for, so we need one allocation per direction. But that's okay, so it's not 1,000 allocations, it's just one. So we need to take care of these differently. So, but the but the DX image and the DX image and the DY image can be set at once. So I should be able to do that. So if we're here, right? I can't. Oh, maybe it's this. Bathroom break. Hmm. So most likely I need to I need to do that here up here and then just return it, right? So so most likely I can do something like this. Okay, let's go some steps back. Let's take this part of the code and like this. And then down here I simply say the X image is the X image. And basically here we can say, so this is the transpose. So we go here. Okay. So let's get rid of all that. So okay, and here we do the scaling. So max type is here T. And I can't do that because now I'm destroying my image. So this here, the bottom part needs to go somewhere else. So what about this and more image is width times height, and then this is a T. No, this is a T, and this is a T. And in the beginning, this is going in circles. And in the beginning, we set this. So after we processed it one time, dx image as basically the derivative in x direction. But in the end, we need the final image in both. So maybe so maybe that was not the way. So when we do that here and we skip the scaling step and just collect the maximum, then maybe it works. So here we say self dx image and self dx image. square root. Okay, so that self dy image, and we switch the coordinates to make the transpose one, and here we say self dot dy image on x times height plus y is self dot dx image on y times width plus x. Why are you so keen on putting these two lines together? Okay, now it stays. So, and maximum okay, so this can go and this can go. So because we're taking that from the instance, okay. This can go and this can go because this is self.height and this is self.width, and okay. this is const ID is y and this. Okay, and then let's replace all these like this. ID ID, and this is also ID. So, and this is not ID. This is the transposed version. Const ID transpose is that, and this is self.height. With the X, yeah, ID transposed. Okay, so now we need to be careful. So that is ID transposed. It's the same as the untransposed. And here it's the untransposed. Untransposed. That's the mix factor. What are we going to do with the original one? these things, and we don't want to allocate them for each line. So we need to do it outside. Okay. Let's do that outside. Here. So these need to be okay. And these need to be width, right? Yep. And these are of type T. What's wrong here? It's never mutated. Okay. Yeah, I know. Okay. So this is probably also never mutated for now. And do we need to clear them, or do we set them all? We'll see. Okay. YP and YM.
He.
Hi, Proston. I am about to make everything super fast. So we fixed that. Self-normalization is initiated. We return the factor.
Just arrived.
And here we say self dot is true. Okay, so we got that. So why does it still say it's never mutated? Ah, wait, I remember. So now I need to say here, like this, like this. Okay. And then we're done. And we need to do the same down here. The big question is, okay, let's see if that thing works. Yeah, I know you're not a var. I hope I can reallocate the stuff here. So is there an allocator realloc? A new size for an existing allocation, which can be larger, smaller, or the same size as the old memory. The result is an array of new n. And it gives any type. Okay, so can I just say something like this? Realloc old mem is yp and new size is not width but self.height, and we do the same for ym. Realloc ym. So, and then it should fit down here. And we say yp and ym. So, honestly, we don't need the allocator here anymore. So if we go down here, we can remove that. So how was your Saturday night? What we're doing with the input? So reading the input here, and we're setting the output. Or shouldn't we be able to just say data and forget that here? reading, we're setting YP, and here we're also only reading until we're done. Okay, and then we can say data. And all of the elements are set, so we don't need to initialize them with something. So that can go. Okay, and let's just put them together. It's ugly anyway. So now we can go here and say this is not a row. This is just one row. Okay. And this is just one column. Okay. So we don't need the memset. Okay. And we need to take care of the original image, right? Do we? I think so. Let's make original image T. So sigma mix factor image with height. Let's put the allocator here. Allocator is standard mem allocator. Okay, so alloc T, and the size is width times height. Okay, so that's our first copy that we need. That's the second copy. and think we can skip this and skip that. And I think I need to do try here. No, wrong place. Here. Then the arrow gets promoted upwards, I think. I never checked that. So let's do one more and say, let's call it, yeah, orange image. Okay, let's see if we okay, let's do it like this. So first we need function initialize image, and here we get an image which is U8 like this. Doesn't do much, except we will do these things in the function. So what if I do it this like that? Okay, so let's just width is U16 and height is also unsigned 16. And then I think we need to okay, let's say dx image is t, dy image is also t, and let's put the original one image is also T. So then we have it here. So we got image, and here in the same loop we say above auric image I is, can I do it like this? No, of course I can't. So this comment is not true anymore. Okay, so it still says, So now what if I call initialize image with image with height auric image, dx image, and dy image. It still thinks we never mutated. Okay, yeah, because I will never learn. Like this, and like this. But in fact, we don't need to do that here, right? It's okay. So we got the memory. So I think we need to, so if that works, I don't know. Defer allocator free auric image. Like this, and here it's dy image, and here it's dx image. Okay, so like this, then we take this out because it's useless here. We still assign it, but in a filter the first thing we do is that we call that, and of course I call it data here. So, and here it can be self.width, self.height, self.original image, I will break everything. So we initialize that. So then we I don't know. That's supposed to be const, right? Because it's a pointer and I can just mutate the data behind the pointer. I don't know. Let's try it like this and see what happens. So then we allocate these for the lines. We filter each line. We filter each. So we reallocate the memory. Reallocate the memory in case the columns case width and height are not equal. Then we do it here. So now we got the data. Now we got data here. And so, and this is not the original anymore. It's self.org image. And the max is good. So we don't need that anymore. So there's still something wrong somewhere. So image is unused, yes, because we don't need it here. We just need to know the width and the height. And if that stays the same, it's okay. So we allocate here. So where's the, well, okay, so wait, by initialize image. Let's kick that out here. Yeah, I know. We do it here and say as a first step. No, not as a first step, but as one of the steps, we say allocator. And that's of type as standard mem allocator. And expects a comma. So now we got that. And here we can say dot allocator is allocator. Okay. So and here we can say self.allocator and self.allocator. Why is the documentation? Okay, so quick documentation, navigation settings, that's off. Code completion. Pop-ups. Okay, so no, never. Never. Nope. And okay. So apply. Let's see if it's shutting up a bit more. Okay. And if I say here, yeah, that's much better. And then we have a realloc here. Self dot realloc. Okay. At least it seems the code is not read anymore. So, and how I envision that for my main file is as follows. We say image array, okay, so we fill it with something, and then we say const derivative filter is of type, how did I call it? Derivative filter. Oh yeah, I need to, so filter dot derivative filter, and the type is, for the moment, F32, right? And I don't want to do it like that. I want to say is init now nothing is showing up anymore. Christ. I think I need to do it like that. Right. Okay, then I need to call init, but that wasn't, okay, so that was a different way to do that. And I used it somewhere in filter. Wait, we need to check. So here I said c.init. Okay. So why can I do this, but can't do it for my own? So wait, we define C to be complex 32. Let's do that here. Const f is filter.derivative Okay, so now do that F32 like that. And is it now possible to say f.init? What did I do wrong? It's a public function. That returns a struct to itself. Do we? Maybe I forgot that. No, no. It's okay. Return struct. And this struct should have a member in it. And that's the same thing as in complex. T type Wait. Okay, so here it returns type F32, and that's kind of not what I want, right? And if I go to my filter here, it doesn't do that. It returns complex. Oh, maybe the init function. What does the init function? It returns itself, and we also do that, right? No, we don't. Yeah, we return self with all these values in it. Okay, let's take this here. Okay, so now I got brain freeze for some reason. So in here, this returns a struct. Ah, okay, I see it. now all should be fine. There you go. Whew. Okay, so here we say that is filter sigma. We say that is filter factor. There you go. Here we say texture width and texture height. And allocator will be std mem allocator standard heap. Okay, and the allocator will be, okay, let's put that down. So standard heap So now we got our derivative filter, and here we just say okay, something is wrong still. Where's the enter? Enter insert suggestion, even if completion popper is not focused. Yeah. Okay. Derivative filter. And maybe that should be public. And that should not be public. Okay, let's go ahead and see what we did wrong. So found error out of memory. Error. Expected type. Found error. Okay. I don't know. Maybe we simply since so much stuff can go wrong here, we just say like this. No, here it can't go wrong, right? Allocator only in the init. So if we propagate that upward, let's see if that makes a difference. So go ahead. No field or member function named filter raylib data. Maybe okay, wait, missing struct scale factor, a factor, scale factor, missing struct field YP. Okay. I think we solved YP and YM differently, right? So here we can just say false dot scale factor is 0. Okay. Now we got this one. Okay, so try that derivative filter rated data. And it says no field or member function named filter raylib data. This is confusing. Why does it say filter derivative filter dot init? Arrow union. Maybe it's wrong here, right? No, it's not. So okay, that error expected type. Yeah, wait, what? How can I do that? Like this? So if I call a member function. Ah, no, wait. Try self. Okay. Okay. Error member function expected 3 arguments found 4. That's not good because oh yeah, I know, because we don't need that anymore. Data. Okay. I need the same like this. So I think we got the same thing here, right? Now we got Sigma and all the rest of the kids. Okay. Cannot assign constant. That's unfortunate. Why is that a constant? So I think I can't do that here, right? Do I really need to say, So this is a constant, okay. So I need to allocate memory for that, like var is initialized is false, and then say is initialized like this. Local variable is never mutated. Okay, so and this will get the same thing here if we can't change. Okay. Not sure. Is initialized. Is it? It's only problematic for them here because they are not constant. Error. Union is ignored. Let's fix that first. Okay, so maybe I'm doing this completely wrong. So these, okay. So something like that is possible, right? So the question is that a class variable, or is that for each instance? Okay, so for the moment, let's say it's okay. Make it false. And we don't set it. We just try it out, because I guess we could run into more trouble later on. So I think when we calculate the normalization factor, we just don't set it here, and it will be just recalculated. I want to see what else we're running into. I don't want to build and run, I want build and debug. And is that bad if I ignore it? So wait, old memory. So old memory, new size, and it returns an error of old memory. New allocation. This function only fails on out of memory conditions, unlike remap, resize. Resize, which returns false when the allocator implementation cannot change the size without reallocating. Okay, so now we want realloc. So I can do something like this. Incompatible types. Okay, so what? Yeah, of course, here a index is missing. Root source file struct filter has no member named derivative filter 1D. Yeah, that's okay, because this was test anyway. Panic, integer overflow. Try alloc. Usize. Okay, then that's clear. We need width and height to be usize. Usize. That makes much more sense. Okay, and everywhere else. So we got here. This is usize. This is usize somewhere else. Let's call for U16 here and just replace it with usize. Yeah. So replace that one. Okay. Okay, we saw a window and that's about it. Float from int image. Segmentation fault. It's called here image array. Texture width and texture height, and that's the same. So the big thing is can we debug that? data. So, and this is okay, we have it here. This should be the same as 265 squared. Okay. Width and height is optimized out. That's good. Wow. What? Wait, auric image is a struct. Probably you do that as well. I don't know. Float from int. Okay, I don't know. Because most of the stuff we did is really just writing it down as I think it could work, and that's good recipe for disaster. Random effect. Oh, Christ. Oh god. Reason for the segfault. I'll make a quick bathroom break. Okay. So segfault is a use after free in derivative filter.init evidence. Okay, so we allocate these. Okay, so these on basically they will be freed when they go out of scope. That means the return derivative filter holds dangling slices as soon as init returns. Okay, those buffers have already been freed. The first right here, okay, then touches invalid memory. Okay, so the crash reason is that these arrays point to freed memories. There are also 2 additional allocation slice bugs nearby. So we use, so we ignore the result of realloc. Realloc can move the buffer, so discarding the return slice, okay, can leave YP and YM dangling, okay. Okay, so let's check. So okay, so now I understand it, but the thing is, I need to free it at some point. So we need to free them. Okay, so wait. All right. First question. When the whole filter instance needs a custom free method so that I can free memory when the filter is no longer needed. How is this implemented in Zig ? Dinit. Okay, so in Zig, this is usually an explicit dinit method on the owning struct. Okay, let's do that first. So let's put it down here, or maybe not, maybe put it close to init. And then we say here, does this thing need to be public? Probably. dinit. Okay. And this is void. Okay, and then we say self.allocator.free self.original image, and here we say dx image and dy image. Okay, good. And then self.original image. Okay, that's what, the address of an empty struct. So, and then it does something like I guess it means if an error happens in that function, init allocates and returns the struct. Dinit frees everything in the struct owns. Use arrow defer in init, not defer. Arrow defer only runs if init fails part way through. Okay, so that was it. Dinit should usually take self. Okay, so dinit should usually take self because we mutate if a struct owns memory, give it init and dinit. If it does not own memory, don't free in dinit. Okay, yeah. Okay, so and then we need in main here we can say where's the filter? F init, and then we say defer dinit like this. Okay. And then it said something. There are 2 additional allocation slice boxes nearby. Ignores the result of realloc. Okay, so we need to find out this function requests a new size. Okay, so I think what I need to do here is say yp and YM, right? Found const t. Okay, so right, because it's woo. Okay. Now it looks good, right?
Yeah.
Okay, so I honestly I thought I go to bed without any success here, because we basically refactored the whole thing.
And very flow.
To something that, yeah. So what I do now is, so when I basically use a very big image, right, then
And faster, ha ha ha.
yeah, it's faster, right? But it's not only faster because it's faster. It's also faster because I use a smaller texture and just show it bigger. So what you see here is basically, I don't know, 256 by 256 texture increased to size of 1,000 by 1,000. So, and I didn't do it because I wanted to have it faster. I did do it because when I do it on a very large image, I need to adapt the filter parameters. So, and I didn't want to do it because I wanted to basically compare it with the one we had. So the unfortunate thing here is because I accidentally discovered something truly amazing, which is we were somewhere here. So we scale this whole thing. Okay, and I think what I tried in between is, okay, so what happens if we really shrink it down? I'm not sure if that works, by the way, but we will see. So what I tried was something like self.dx image is I think the minimum of self.dx dx image ID, and I think I used 4.0. It's completely arbitrary. We do the same for the dy image. Only with it transposed. Dy image. I know we don't need to do that, do we? No, because we need to reinitialize the thing anyway. Goodness, no. Yeah, so we only need this here. Let's see. And then the whole thing gets squeezed down exactly like this, only better. And let's increase it a bit. Wait, was it? Ah, I know. Okay, so yeah. And then we have such a nice effect. Let's say 8, I don't know. And by the way, we're still not running in fully compiled mode. We still run in debug mode. Yeah, so I think 10. So why didn't, so 5 didn't work. What about 6? Yeah, that's too noisy. Okay, so we got options. Let's, for the moment, take this out. Or no, let's keep it in and just make a comment. Okay, basically, all right, so what we have now is in our main. So we set everything up, but the major loop here, that's the main loop, right? That runs over and over again. So first we simply calculate the filter on the current image. Then we set the texture to the current image, and then we just draw it, right? And the stuff here is only to make the texture, basically the small texture, expand to the whole image. And right, and then it starts over again. It again just calculates the filters, which gives us the next small move, and then and so on and so forth. So what we have not done is colorizing the stuff. The thing is, we could do that pretty easy. So what we get out here is essentially an array of numbers, of integer numbers from 0 to 255. Let's look again. So in the filter, we end up with this thing, and we and we convert that to an integer right here. Okay, so the easy way would be to say we just make a new file, colorize. So, and it has a function, pop function, colorize texture. So am I supposed to do this, or can I just say this? I'm still confused. What is allocator? So they use camel case. We will do the same texture. So this will get nothing. We don't even need the dimension of the image because we do it pixel by pixel. So this is U8 and data, and then we say output U8. So, and if we do it like this, we can simply allocate the memory once and in main, right, and reuse it. And it's void. So, and now we need to think about how we can colorize the data. And for that, we could go back to our example here where we did that, right? So, and this is actually pretty easy. So first we search for the help. We don't search for the help. Color scheme. Color schemes, there we go. So we got these here. So what really works is what we had here is Starry Night. This is somewhere here, right? So you see it's a gradient from dark to bright yellow, from darkish bluish greenish to something brownish yellow. And what we could do is we simply select a nice one. So we could, for instance, we just try temperature map. And then we ask ourselves, is that what looks really good? I don't know. What else we got? So my experience is that if we have too many colors in there, so it should be gradually, right? So we don't want like bands like in the bright bands or the dark bands. That's not really, doesn't work. So, and if we have too many colors, it's also kind of awkward. So what's with mint colors? Oh, no. That's an immediate no. Okay, so no mint colors. Mint colors are bad. What else we got? So we could try rainbow. I don't know. It's okay, but it's a bit. First, it's a bit dark, I think, and then it's very, I don't know, intense. I hope you can see it, right? Yeah. I mean, it's not bad. Okay, last try, green pink tones, and then we decide. Green pink tones.
Cherry tones.
Cherry tones, okay. Let's try cherry tones. So with cherry tones, we have the problem that we don't have really colors, right? It's just one color to white. Let's try solar colors. I can't speak anymore. Solar colors. It's similar to cherry tones, but I think it has a bit of yellow in there.
UFF no haha.
Okay, so let's go with sunset colors. It looks like it's okay. I think it's not an immediate no, and we can implement more of them. Okay, so basically what we need is the following. So here, so we have a function, and the function, maybe I should put that. Oh, I forgot everything. Okay, so the function gets an x, and the x is just one number, right? Real. So what we need to output is basically RGB, right? So an RGB is basically the gradient, right? So what we know is basically if x goes something like from 0 to 1, or in our case from 0 to 255, right? Then we want our output to be 0 to 255, and this 3 times. And how this mapping exactly works is basically defined by the color gradient. So what I can do is I say color data, sunset colors, and then I think I can say just 0, okay, or 1, and that's white. And we can say everything in the middle. So see, and this is where they're coming from. So what we could do is basically do a table from x 0 to 1 and 256, and then we put x here, and then we get all colors of the color gradient. Okay. So, and I think there are, we can do basically create a function or whatever, right? But the easiest way is just if we have a table. So what we need is a way to have a lookup table. Yeah. So let's first create a lookup table for us. Okay, so how am I going to do that? I think so I think one of these things is just a color. So we could first turn that into a list, and then we get the color outputs. And then we say, how many do we have? So here should be 255, right? Okay. So now we got 255. And these things, we don't want them like this. We want to say times 255. And then we just gone around them. So these are our color codes. So if we see in our image a pixel with the value of 0, it will get the new value, the new RGB value of 0, 0, 0. And yeah, so, and I'm pretty sure we need also an alpha value. Where did I see that? Oh, wait. Let's go back to main. And somewhere here I used white color. RL color. Okay. Well, that's not the one we were looking at, or what I was after. I was after something else. I was after the image struct, because here we have the pixel format. There we go. So we need uncompressed something. So like for instance that here, uncompressed 888. So for each entry, so, and we have uncompressed, okay, so in here we have RGB and everything is 8-bit. So everything goes from 0 to 255. And this will be our way to go. Perfect. Okay, so we got that. And now we need to bring that in some form that so let's see. Okay, no, here. Can I have a const? Let's see if I have a const. Can I have a const? So table. This is called colors sunset. And this is going to be a is there are tuples? I don't know. Do we have something like a tuple in? No. No. Wait, let's check. So zig tuples struct without field names. Okay. So let's see, without field names. So if I have something like const test is 1, 2, 3. I can't do that. Why? Identifier expected. What? I don't know. Christ. I think test is okay. Bloop. So struct compile time int. So the big question is, can I do something like sunset colors? I don't know how to define them, but what I do want to have is, how can I initialize an array? Obviously that's not the way. Like this. Crazy. Let's go back to here. So they have an enum here, but I don't. I don't want an enum, I just want a packed struct. I'm just scrolling through and trying to find something that looks like what I want. Okay. No, 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 no. Okay, then we need to check the Zik array of structs. Static array struct elements. Let's see. So const nodes node event. But I don't need the names, I just need the values. Okay. Let's go with that. I don't know. I don't care. So we need const raylib is import raylib, and then we want to say sunset colors is essentially a list of an array of 265 RL come on. RL color. Import raylib. There you go. And then everything works. So. Okay, so I screwed up before. What am I doing? Okay. So, and now I should be able to say punct R is 0, G is, I don't know, 1, B is whatever, and A is something like that. No, that's not right. Okay. Why doesn't it know something? It doesn't give me any completion, and I don't know why. Okay, so but basically this is the format, something like that. If we know that it works, right? Then okay, and then we can say const A is sunset colors 0. Okay, just let me just recompile. Colorize is still wrong for some reason. Unused function parameter. Okay. Okay, so then just use it. And like this. And of course, and then let's just say here const colors is import colorize. Okay. I hope, I'm not sure, maybe it's okay. Let's say this stuff works, right? Then what we need is all the colors in that format, and then we can just say, okay, so we go through the data. So my plan is the following, right? We say for something like that. We say const the current color is color sunset I. Oh. So like this, and then we can do we say here var j is 0, and then we say output j, can I do something like that, is c dot red. I can't do that. C dot red, and oh, it doesn't, what? Green. We need another one. No, we don't need another one. So like this, and blue, red, green, blue. Okay, so and then basically we have this done. And this should never segfault because U8 cannot be larger than 256 or 255. And then we have basically converted a gray level image into a colorized output. And the only thing we need all these definitions. And here we will go here and exactly create that. So we round this, and then we say, okay, C to string, and this is basically a tuple R, G, and B, and we say I think I need a toString there, comma, red, green, and another comma, and blue. And then we need the closing stuff, which is that and the comma. Yep. toString, toString, and toString. Okay, and this is totally wrong. It's not right yet. So here we need a dot R is, dot G is, and dot B is. So then we can say, let's take this function C to string and map it over. Okay, and then we need string join. I think it's called string riffle. And as a separator, we want, so, like this. Okay, we can take that. And try our luck. Okay, so that can go, and this can go. Oh, no, it didn't put that. Okay, I don't mind. All in one line, for Christ's sake. Why would you do that? Okay. That goes to the suggestion box. Reformatting a file. A file will often remove line breaks that are wanted. So the big thing is, can this be done? So now let's just use the function first. So we go here and we say var image color array, and this is texture height times texture width times 3 U8 is undefined. Okay. And right here, after we did that, we should be able to say colorize texture. The input is the image array, and the output is the image color array. Okay. Now let's see if that. So now we have error. Comp time int. But I said it's a variable. I don't know, usize. Is it still comp time? Okay, now we're getting to the fun part. Missing struct field A. Oh yeah, oh yeah. Because we need that. So back to the drawing board here. And then we just say here, comma, dot A is 0. Okay. Copy. And let's go to the end. Like this, and then we will take that one and put it up front like this and get rid of that, and probably we go here and make a small indent, so like this. So now we're getting to the nitty-gritty part. So what is it? Panic, index out of bound, index 265. Like what? Ah, of course. Woo! So of course we don't want the I here. We want the value. And the value is data I. And this cannot be more than. Okay, so that works. If this indeed will be good, then we can say So image array, we set it here. Then we do the same here. Const color image is rl.image is okay. And here we want data, in that case, is pointer cast image color array. Wait, we need that here. Why is there like this? Okay, yeah. Then format is rl pixel format dot uncompressed, and we want it uncompressed RGB. Like this. So dot height is texture height. Dot width is texture width. And maps is 1. Okay. So we got that. So I think here we can say color image trilinear. Okay. Okay. So here we say it filters the image array, and then we go here, take that one, here we write everything in image color array, and then we say we update the texture with image color array. So let's see what we got wrong. Unused local constant, yeah, because we don't need the image anymore. Just say for the moment. Woo! I hope to God you're still here. Nice. Okay, let me see if we can do it like that. 0.8. Nice. Okay, and then let's go to filter and bring this line that we commented out back in. And we probably need to lower that a bit, like 7. Okay, so that looks good. So let's see if we can make a quick video of that. So we got peak. I don't know, WebM, MP4. Okay. Let's put that just here. Gradient effect. Oh no, I closed the wrong thing. So do I have some kind of preference here?
It looks too good.
Yeah, it looks good. It's resolution downsampling. No. Delays. No. No. I just want high quality. Okay, let's make another try with the WebM. Let's see if that so we also call that gradient effect. So let's see. So the MP4 is 4 meg. This one is this is bad. Maybe it's my player. I don't know. Let's use. Oh no, I use VLC. No. Oh god, it's stuttering. Good. Then let's use this one. No, I'm going to make a lovely last try. I think my my screen recorder can do that. Can it? Let's see. No, that's not what I wanted. Here like this. Selection. I can do that. Okay, like this. Maybe. It's enough. Okay. So where did it write that? Maybe in videos. screenshots. I don't know. Pictures, screenshots. No. Hmm. Christ, where does it write the stuff? Okay. Shown files. Oh, here we go. Select. Yeah, that looks much better. Okay, so we use that. And then we head over to, where do we share that? Maybe on X. So let's see if we can media, maybe like this. Christ, I already forgot where it put it. Videos, screencasts. Videos and screencasts. There you go. Ah, it doesn't allow me to do WebM. Okay. Okay, I will do that off screen. All right, so it's really, really late here. It's already after 6 o'clock, almost 7. It was a lovely night. We got a lot of stuff ready. We refactored the whole filter thing. I think it's okay for now. We did not take a closer look if it's really okay. We will do that. And we colorized it. Okay, so everyone have a great night or a great evening or a great morning. See you hopefully soon. Let's see what we do next.